answer for those questions in front of you. I'm sure every day I am into PowerPoint slide. So every day we have contents in the PowerPoint presentation, and we are moving one by one on the content. How do you think slides are arranged in PowerPoint presentation? So let's assume.
Ma'am, they're arranged in some sort of a list, I guess.
List.
Because
no, we will come to technical term, but how it is arranged. So you take the current presentation. I have 34 slides.
Number wise.
Here I have 34.
In sequence.
In sequence. Good. One after another. I have totally 34 slides. What else you have observed? In a sequence, one after another. When I am in second slide, if I want to go next, where it will go?
Number 3.
We'll go to number 3. When I am in number 3, if I press next or enter, 4, 5, in one after another. That means if I am in 6th slide, if I go forward, it will go to 7th slide. If I go forward, it will go to 5th slide. So connection one after another. One slide is connected with another slide. So 5th slide is not connected with 10th slide. 5th slide is not connected with 8th slide. 5th is not connected with 20th slide. No, 5th has been connected with 6th. 6th with 7th, 7th with 8, go on. Can you relate? So the slides are arranged in such the way each slide is having a connection. So one with the other one. First with second, second with third, third with fourth, it goes on until it reaches the last slide. Same thing is applicable for Word document. We are navigating from one page to another in a Word. So as soon as if you have turned on a Kindle or reader, so it starts reading from first line in first page, it will go to last line in first page. As soon as it completed the last line, it will go to the second page, and then third, and then fourth. Likewise, it goes on. That means one page and another page should connected in order to have a sequence, continuation. So when you are in a playlist, what do you mean by playlist?
List of songs. Videos.
When you are in a music player, there will be so many songs, but all the songs will be there. You can create your own playlist. So I can have a playlist with 10 songs. So if I turn on the playlist, it starts playing from first song, second song, third song. One after another.
It's may shuffle.
Shuffling order is also there. Random order, shuffling order is also there. How the user is able to navigate from one song to another.
By clicking next.
So web browser. So whenever if you are in browsing, we are browsing and we will maintain. There will be a session and there is a back button and forward button. So I started with one page. I've redirected to another page. When you click back, it will go to the previous page. The browser maintains the link of web page explored by the user. That allows the user to move from one page to next page, not in the same website, in different website. So the browser is keeping track of the pages which you have browsed and you have I cannot jump from third website to fifth website. It will go in the order sequence. So let's say I opened 5 pages in the same tab. When you click back, it will go to the previous page which you have viewed. Again, the previous one. Likewise, it goes on. How is data of origin and destination managed by the application? So you can give from and to, source and destination in your GPS navigation. Irrespective of any number of places, it will maintain. Let's say you have 10 stages starting from this point. It will go to first stage, first to second, second to third, third to fourth. Likewise, 10th stage, and then it will reach the destination. Again, there is a sequence, flow, one after another. So how one place and another place has been related. So when you are in a navigation of 10 kilometers, so in between you have 10 places. All the 10 places are connected one after another. Just relate with these examples. What do you think is common in all these scenarios?
One after another.
One after another. One is having a connection with another. That is having the connection with next, so that we can reach the destination. It will continue till it reaches to the end. So this type of connection between one data and other data, one with another connection, can be established with the help of linked list data structure. Yes, I'm going to organize my data in such the way one will have a connection with another. And apart from that, I will perform various operations such as inserting the data, deleting the data, updating the data, traversing the data from first to last to first. So in this session, we will be working with linear data structure, which is linked list. Linear, one after another data. In this session, we will discuss about defining linked list singly and doubly. Singly is only one direction, forward direction. Doubly will go both forward and backward. Listen carefully. Linked list is a dynamic data structure. It allows memory to be allocated as it is when it is required. I'll repeat again. We have come across with array type of data handling, which is static memory allocation, static data structure. Whereas linked list falls under dynamic data structure. Whenever it is required, memory will be allocated. And it consists of chain of elements. Each element is referred with the technical term called as node. So before starting with linked list, I would like to introduce a small thing about static structure and dynamic structure. Please pay attention. Don't confuse with the term static and non-static of Java program. That static is different. Whereas apart from that, you have another term called as static versus dynamic. What do you mean by static with dynamic term? Permanent. All right. Any other term?
Doesn't change. Constant.
Constant. Good. Any other term? Fixed.
Immutable.
Immutable, which cannot be changed. Right? Right.
Yes.
Whatever the term you said, it's applicable for static. Constant, fixed memory, which cannot be changed memory. Very good example for static is array and dynamic is linked list. For example, if I have an array, so I have an array of, let's assume 3 items, 10, 20, 30. If I have array of 3 items, I hope You can recollect. So 10, 20, 30 will be stored as, oh my God, I missed variable. Huh? Let me make it as roll number. So this will store as a roll of 0, roll of 1, roll of 2. And imagine like it is stored in a memory of 5001, 5005, 5009. Continuous memory allocation, contiguous memory allocation. I'm just allocating 4 bytes, or let me make it simple. 5002, 5003 memory, continuous memory. Imagine each memory is having 4 bytes. So let's assume I have marks and I have 2 marks. And these 2 marks, so I have stored here marks of 0, marks of 1, 78, 98. Imagine like it is taking 5004 memory, 5005 memory. So far, is that clear?
Yes, ma'am.
Ma'am.
I've not introduced anything new. Whatever we discussed in array in terms of memory allocation, I'm discussing. All right. It's working fine, no problem. Throughout the program, I allocated the memory and the memory is fixed. Can I able to change memory address of 5002? Memory address of 5005? It is not possible. Fixed memory in static. Values can be changed. That story is different. I'm talking about memory address. Memory is fixed throughout the program. When we consider array, it is a contiguous memory allocation. So let's assume if I want to expand roll number array, is it possible? So I want to expand from 3 to 10. So I want to store 10 roll number. Is it possible?
No, ma'am.
Not possible. Why? Because according to array, according to array, it will store in contiguous memory. Initially, I allocated 3 values, so 3 memory allocated. And the next continuous memory has been taken by mark array. I cannot expand. So let's assume I have shrunken my array. I've deleted an array from 3 to 2. So this data will be deallocated. Can I able to allocate this 5003 for any other variable? It's not possible. Throughout the application, this memory will be wasted. So when I have a fixed memory allocation, I cannot able to expand the size. I cannot able to shrinken my array. Either I will get memory overflow or underflow problem. So because of this problem, we are moving from static allocation to dynamic allocation. Am I making it sense? We have a contiguous memory allocation, so I cannot expand the size. I cannot, even if I delete the record, memory wastage will happen. Is that clear?
Yes, ma'am.
Yes, ma'am.
So because of this reason, we are going to the type called as dynamic memory allocation. So in dynamic memory allocation, listen carefully, you have a vast memory. So imagine like you have some 10,000 memory. So you have memory address from 2001 to 2100. So you have vast memory. And the data will not store in order. if I want to store the record, let's assume I want to store the record. If I want to store 10, 20, 30, it will not store in the continuous order. I assume like I want to store 10. At that time, my 2004 memory is free. It will insert the value over here. Roll of 0. 10, 20, when I want to allocate 20, this memory is free. Let's assume 2009 memory. I'm allocating here. So when I have 30, this memory is free. I'm allocating. So if I have the next array, let's assume mark array. So when mark array comes into the picture, wherever it found memory, it will allocate the value. It's a random allocation of memory, and it will allocate. And by the way, you have vast memory. All right, listen carefully. So I have a vast memory where whenever I am inserting the value, whichever the memory is free, my compiler will allocate the data over there.
Ma'am, mark 198, I think.
Yeah, thank you. So now if I want to expand my roll number from 3 to 10, is it possible?
No, ma'am.
Think and answer me.
Yes, ma'am, we can.
Yes, man, we can expand.
So how? Earlier I said I cannot expand because as per the order 5004 needs to be allocated for array, but 5004 is allocated for some other array. So because of that I cannot able to expand. Even though if I shrinken, memory wastage will happen. Whereas if you take here in dynamic memory allocation, I have huge memory. So if I want to expand my array from 3 values to 10 values, it is possible. Because we have a vast memory. Wherever the memory is free, it will allocate. I have not completed listen. If I want to shrinken, assume like I'm going to delete this 30. Can I delete? Yeah, I can delete. This memory will be free. If suppose if you have some other array, student's name array, if this memory is free, this memory will be allocated by some other array. So we will not have a problem of expanding the data size as well as deleting will not leads to data memory wastage. But the problem is when I am storing the data in dynamic memory, it will be stored in a random order. It is not contiguous. See here, 10 is in 2004, 20 in 2009, and 30 in 2001. There is no order, continuous. It is not continuous. So in order to relate 10 with 20, 20 with 30, we have the concept called as linked list. Anyway, one and another has to be connected. How we are connecting? Let's discuss. Now read the point. It is a dynamic data structure. It allows memory to be allocated as whenever it is required. So whenever it is required, you can allocate the memory. Please read the second point. It consists of chain of elements. So it will be having elements, group of elements, chain of elements, in which each element is referred to as node. Node is a basic building block of linked list. It consists of two parts. The first part is data, which is my actual information. The second part is link, address of next node. This is a diagrammatic representation. Data, address of next node, which is completely called as node. With this point, let me come back to this Excel. So if you see, it is not continuous order. Even though I don't have a problem with memory, dynamic allocation, there is no continuous order. So in order to keep track of this data, chain of data, one after another, we are introducing the concept of linked list. So in linked list, you will be having a node. So in a node, there will be two parts. So we will call something called as node. Node consists of data and we call it as link. Link is nothing but address of next data, next node. Let me make it as next node. For example, you take our 10. So if you take the first node is my 2004 memory. And by the way, node is called as address. And this address consists of data and address of next data. In our case, I'll be having a node. So this is my node, my first node, which is nothing but 2004 memory, consists of data. And the second part is it should consist of address of next data. What is the address of next data? 10. What is the next data? 20. Where 20 is located?
2009.
Similarly, you will be having the next node, which is 2009 node, holding 20 and address of 30. And you will be having the third node, which is 2001 node, which consists of 30. And do you have any other element after 30?
No.
No.
None. That's all. Representing a data in the form of node, so that one node and another node will have a connection. Node is nothing but my data memory address. In 2004, it will not hold only 10. It will hold 10 as well as address of next node, which is 2009. Take
Can
time.
you please explain again? Actually, it's my connection issue.
All right. From where you have left the session?
Actually, the dynamic part I missed.
How can I repeat? I'll say, try to relate with the topic. Point number 1, I said in dynamic, you will have a vast memory. Whichever the memory is free, the data will be stored and there will not be an order. The data will not store in a continuous order. Yes, Mainak.
Yes, ma'am. That part I understand.
So in order to establish the continuous data storage, we introduce the concept of linked list. In linked list, we will represent we will represent element. Each element in a linked list is referred to as node. Node is a basic building block of linked list, and it consists of two parts. The first part is data and the second part is address of next data. We can call it as link. So every element consists of two parts. So if in our case, if I take my first node, which is nothing but 2004 address, in this node, in the memory address, it will not store 10 alone. Earlier, we will have, in memory, we will have data alone. But in linked list, along with the memory, so along with the memory, I can say, we will have address. So in 2004 node memory, I'll have 10 as well as address of next node. What is the next value? 20th address. If I refer 2009, 2009 is referring the another node which is holding 20 and address of next node, which is nothing but 30th address. And 30 is my last value. It does not consist of next node, so make it as null. Is that clear?
Yes, ma'am.
Right. Can I connect 10th with 30? Is it possible?
Yes, ma'am.
How it is possible? I cannot connect 10 with 30. I can connect only to 20. From 20, I can go to 30.
We can change the address.
Yeah, because 10 is having address of 20. I cannot jump from first element to third element. It's not possible in linked list. So I want all of you to understand how the linked list, we are just discussing about the first slide. You can relate the diagram or you can relate the theory. It consists of chain of elements in which each element is referred to as node. Node is a basic building block. It consists of data and link. Link is nothing but address of next data. All the nodes in linked list are present at arbitrary memory location. Real world data will be located. See here, nodes are called as memory location. Each node will be having memory. But in that memory, we will have data as well as address of next data. Since the last node does not point to any other node, so it is pointing to null. Listen carefully. So this is the address of first data, 2403. It is holding some number, let's assume 11. And 3352 is the address of next node. Here let's assume 22. Here assume 33. So each node having data and address of next data. So 1012 is the address of next data. To keep track of first node, anyway, I want to start. So in order to keep track of first node, we will declare a variable or a pointer called as start. Start always point to the first node. So that is enough. because anyway, my first node will have a connection with last. Second. Second will have with third, third to fourth. It will go till it reaches to last. When you will know you reaches to last node?
And these are null in the
When you will come to know we reached the last node?
When the last node doesn't have any address.
When the last node holding the next address is null. Please listen carefully from the beginning. I know it's a tricky topic. Implementation needs hard thinking, so please listen. Again, I'm repeating, if you take the current slide, so this complete data is called, the complete block is called as node. It consists of data and address of next node. So 17 address will be over here. 20th address will be over here. This is linked list. We need to establish a relation in our program. We have three type of linked list. Whatever I discussed now falls under the category singly linked list. 10 will forward only direction. 10 will have a connection with 15. 15 will have a connection with 17. 17 will have a connection with 20. All right. So it will go only forward direction. If I want to connect the backward direction, that is 20 wants to know the detail of 17. 17 wants to know about the detail of 15. 15 wants to know about the detail of 10. Both, if I want to traverse forward and backward, we have doubly linked list. In doubly linked list, node will be divided into three blocks. Center block is our data information. Left will be holding the address of previous node. Right will be holding the address of next node. I'll demonstrate the same with the demo which we discussed. And the last category is called a circular linked list. Circular linked list is similar to singly linked list, but only one difference is it will go only forward direction. The last node has been connected with first node. There will not be null. That's all. Whereas doubly linked list is unique, where it will go forward as well as backward. All right. Please listen. So let us convert singly linked list to doubly linked list. So in doubly linked list, the node will be divided into 3 parts. Guys, are you with me?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Let's convert the same records, irrespective of 3 records or 10 records. Anyway, the idea remains same, right? So this is my node. So I have 3 memory, 2004, 2009 and 2001. So 2004 is holding 10. 2009 holding 20, 2001 holding 30. Is that okay till now?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Fine. So the node is divided into 3 parts. The center part is the data. The left part holding address of previous data. Do we have previous data before 10?
No, ma'am.
No.
No. So we can make it as null. What is the address of next address of 10, which is
2009.
2009. So let's come to 20. So what is the previous address of 20?
2004.
4.
Very good. It is an address of 10. And here it will be holding address of 30. And 30 will be holding at left address of 20, which is nothing but 2009. If I made any mistake, please point out. And do you have any other data after 30? No. So you can make it as null. So by the way, I have both. Is that okay? I can traverse my linked list in both forward direction as well as backward direction. I can start from 10, I can traverse to 20, I can traverse to 30, or I can start from 30, I can traverse to 20 and I can traverse to 10. Take time, analyze. And the only change I want to say for circular linked list is the last node will not be pointing null, whereas it will be connected to start node. Is that clear? Shall we move next?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right. Moving on to the operations we need to do with linked list. So we have four different operations. The operations are inserting the data node, deleting the existing node, updating the data in an existing node, and the last one is traversal. Traversing all the nodes from start to end, that's all. So again, when we are inserting, whenever we are inserting, insertion refers to the process of adding new node to the list. Following algorithm demonstrate how a node is inserted in an empty linked list. I want all of you to clear with the algorithm steps. Only if you clear with algorithm steps, we can convert those steps to program. Else it is difficult to understand and implement in program, Java program. So please pay attention. So let's assume there is an empty, there is no node, nothing. I'm about to insert my first record. So what is the first step? Let's take insertion operation. So no existing record. So what is the first step? There is no record at all. I want to insert first node. It is something like I'm inserting first node, or I can say a new node in linked list. Is that clear what we are gonna to do? It's an empty list. No data, nothing. I am gonna to start with first. I can say first node or I can say new node. And the steps involved in inserting a node in an empty linked list. Empty linked list is point number 1. Allocate a memory for new node. So step 1, allocating the memory for new node. So I need to allocate.
Memory allocation is done at runtime.
Yeah, runtime only. We will use new keyword. So let's assume 7001 memory. I want to create a node. By the way, yeah, as you said, runtime, I'm gonna to allocate a memory. Imagine like I'm allocating 7000 memory for the node. I'm creating the node. Step 1 is clear. Allocate a memory for new node. Step 2, assign a value to the data field of new node. So I created a node, created the node instance, I have allocated a memory. So in that I want to allocate a value. So let's assume my value is 31, allocated. What is the next step? Make the next field of new node point to null. This is my first node. Do I have any other node? No, make it as null. And the last step is make start point towards new node. So make it as start. Point number 1, allocate a memory and create a new node, assign a value. Since this is the first and only one node, make the next address as null and make the newly created node as start node.
Can you repeat it once again?
Yeah. So what is the step 1? Can you read step 1?
Allocate memory for the new code.
So by the way, what we are doing with the algorithm is there is no linked list at all. I'm going to start with the first creation of node. It's an empty list. So in empty list, what I will do, I'll start from first node. So first step, allocate the memory for new node. So new node has been created and this new node is holding some address. 7001 memory has been created. In 7001 memory, assign a value. And this is my first node. I don't have second node at all. So make next address as null. And this is, as I repeating again and again, this is my first node. My first node is going to start node. So make this node as start node. That's all. Shall I continue with next? So let's assume step number 1, we inserted first node. So let me go for second step. Let me insert second node in existing linked list. What I want to do, assume like this is there. I want to insert, let's assume 32 or 41. What is step 1? Anyone can answer.
Create a memory.
Very good. Very good. Correct. Every algorithm, this is our first step. Create a memory, allocate a memory and create a new node. Assume like I'm creating a node and the address is 7045. Second step,
Assign.
It's a data.
assign value. Let's assume 41, 31 and I want to insert 41. And now you need to change some steps. I'll help you, don't worry. So if I insert second node, step 1 is allocate memory, new memory. Allocate memory for new node. Second step, assign value to this newly created node. What is third step?
Point towards the next node.
Point next address as null. Okay, I'm making this as null. But one more important step is think
and make it this
Previous
node
address.
point towards new node.
right. Do I want to connect 7001 with 7045? Yes. For that, what I need to do? Instead of null in 7001, I should make as 7045. Newly created node should be placed as next address of start node. Make start node next address as this newly created node. That's all. That's all. Wait. Yeah. That time algorithm might change. Yeah. If I'm inserting the first node, for 7001, allocate the memory, assign value, point next as null, make it as start node. Whereas If I am going to insert a second node, again allocate a memory, assign a value, make the next address as null. But we have a start node. Start node's next address. Start node's next address was null earlier. Now you want to make only by this way we are establishing a connection between one node and the other node. Same steps will be repeated. Okay. Let's assume I want to insert third node. Slightly varies so that we can merge first and second algorithm and third algorithm in the common way. We are not sure whether it is third item, 10th item or 20th item. So listen carefully. So the first operation we were discussing is insertion operation. So in insertion operation, either you will insert node in empty linked list. Or there will be an existing linked list. There were three options. Let's assume I have an existing linked list. And this is my existing linked list. So in existing linked list, either I can insert new node in beginning, or I can insert new node in middle, or I can insert new node at end. Based on this, my algorithm might differ. If it is in beginning, the algorithm is slightly changing. So whatever the existing start node will be swapped to the currently created node. If it is middle, let's assume 10, 20. I want to insert 15. So that 10 will be connected to 15, 15 will be connected to 20. You need to write an algorithm or program in such a way. If it is end, already there is a node pointing to null. So with that node, you want to connect with the newly created node. Let's assume 35. And that 35 you want to point to null. So depend upon the place where you are inserting, your algorithm might change. Take time, analyze. So let's see whether there were algorithms or not. Yeah. The following algorithm demonstrate how the node is inserted at the beginning. So step number 1, whenever if you are inserting, this will not change. Allocate memory, assign value. Already there is a start node. So that start node next field is gonna to point to the currently created node. So let's assume I have 10, I have 20, I have 30. And this 10 is considered as a start node. But I want to insert 5. So what I want to do? So the expected output is 5, 10, 20 and 30. So what we need to do? Already we have 10, 20, 30. Now I want to add 5 before 10. Earlier 10 was my start node. So I want to hear from you guys. Algorithm is in front of you. Demo is also in front of you. Can't you guess?
Ma'am, can you please explain the fourth point?
Hmm?
The fourth point, ma'am.
Sagar, no, I didn't hear you. What he's telling?
Ma'am, I didn't get the fourth point.
Okay, yeah. Even I didn't complete third point. I am with third point right now. I want anyone to guess or explain what is the third point. Is it possible or not?
Yes, ma'am.
Try. Give a try. Okay. I'm having 10, 20, 30. So I want to insert at the beginning of list. So I'm creating memory for 5. Fifth node, I'm inserting 5 over there. So what I need to do is, I have created a new node called as 5. So this fifth next node, fifth next address, I'm gonna to point to 10. So that 5 and 10 will be connected. And I am making 5 as start. That's all. Whatever the new node I created now, that is 5. 5 next address is gonna to point as start, which is nothing but 10. By the way, I'm connecting 5 and 10. And the last step is I want to make 5 as start. Earlier 10 was start. Now I want to make 5 as start. And with the third point, already I connected 5 with 10. Fifth, the newly created node is 5. Its next address is pointing to the current start node, which was 10. By the way, we are connecting 5 and 10. And the last step is 5, we want newly created node, which is 5. We are making it as start node. Yeah. I know there will be some confusion for few of you. Can you relate this, guys?
Yes, ma'am.
Each algorithm differs slightly. See here. The following algorithm demonstrate how the node is inserted at the end. Again, I'm repeating. Let's assume I have 10, 20, 30. So I have 10, 20, 30. 10 is my start node. 30 is pointing to null. because it's a last node. Assume like I want to have 10, 20, 30, 40 needs to be inserted. Listen carefully step by step. I want to insert 40 where? At the end. As usual, allocate the memory, assign value. Let's assume if it is empty list. Nothing is there. If it is empty, whatever the newly created node, that is gonna to act like a start node, last node, and go to step 6. If it is empty. But if it is not empty, it's not empty in my example. I already have 10, 20, 30. So I want to traverse my node and I want to come to last node. Is it possible to traverse from the beginning to end of your node? Is it possible or not? One by one. Where you will start from start node. Where you will stop till it reaches null. So I want to traverse and I want to come to the node where I am having null value. That's all. Make the next field of last node pointing to the new node. So I need to traverse and I want to come to 30. So 30 is pointing to null previously. Now I want to make 30 is the next node to be pointed to 40, which is a newly created node. And 40th next node will be pointed to null and make 40 as last node if required. That's all. You will traverse and you will reach till 30, which is null previously, and 30th next will be made as 40, the currently created node, and 40 next will be made as null, and which is our last node. Like insertion, we have the other operation, which is delete. Deletion is an operation in linked list where we can remove the specified node. And when you are removing, you need to take care. Where you can remove either in the beginning, middle, end. Let me ask you a question. Let's assume 10 is my start node. So 10 is pointing to 20, 20 is pointing to 30, 30 is pointing to 40, 40 is pointing to 50. So I want to delete 10. What is the procedure?
Make 20 as a start.
That's all. Very good. That's all. It's correct. Only one step. Make 20 as start node. How you will come to know 20 as a start node?
Make it as a null.
No. Think logically.
After
I'm just
in the next after next node.
1 second. Abhilash, you want to give a try? I have 10, 20, 30, 40, 50 and I want to delete 10. What is the procedure? 10 is a start node. Make 20 as null. How you will come to 20, by the way? Because I know only starting 10. Think.
10 is linked to 20.
10 is linked with 20. How it is linked? Tell me logically, algorithm steps. Joel, you want to give a try?
Ma'am.
10. I mean, 10's next node should be null, maybe. I don't know.
Correct.
Yeah.
So 10, which is start. You locate start node, start nodes, next address. Make it as start. That's all. So you have 10, 20. 10 is connected with 20. I know 10 because it is my start node. So what we need to do it is 10th next node. So 10th start node, next node. I want to make it as start. By the way, I'm making 20 as start node. That's all. That's all. Story over. That's all. So I know only start. So starts next, which was 20. Make this as start. By my linked list will traverse from this 20. It will delete and deallocate the memory or leave it. Anyway, it will be unused. My garbage collector will clear. Let's assume I have 10, 20, 30, 40, 50. And for your information, 10 is my start. I want to delete 30. What is the procedure? And I want to get 10, 20, 40 and 50. What is the procedure? Yeah, that should be logically possible. I don't know which one was 20, 40. This is since it is in front of us, we can assign, but think logically. So if I want to delete 30, step number 1, I want to locate 30 as, for example, my node or delete node. All of you got this point?
Yes.
If I want to delete 30, I want to traverse and I want to locate 30 and make 30 as a delete node. Step number 2. Delete nodes previous. What is delete node previous?
20.
What is delete node, by the way? 30. What was 30? 30th previous was 20. So delete node previous nodes next address. Make it as delete nodes next address. So 30th previous node next address is pointing to 30 already. But what I want to do, 30th node previous nodes next address, I want to point as 30th node next address, which is 40. By the way, I'm connecting 20 and 40. That's all. 2 steps. So delete nodes previous node, which was 20. So 20th next address will be 30th next address, which was 40. So 20th next address will be 40. I am connecting 20 and 40. 30 is nowhere in my linked list. Delete is as simple here. So let's assume I want to delete 50. What is the procedure?
Locate 50 and then make it previous one as end.
Locate 50 as delete node. Delete nodes
Previous.
make it as
Null.
very good. So 50 is holding null. So locate 50. 50's previous address is 40. Previous node was 40. So 40th next node make it as null. By the way, we are concluding that list is over here and 50 is unused. It will automatically clear. My list will stop till 40. See, I want all of you to assume not only 10, 20, 30, 40. You just think about this address. This is my start. If I delete start, this is gonna to be my start. Okay, let me complete the last topic and then I'll get into programming. Traversal, how to traverse? Step. How to traverse? You can give a try. I want to print all the values in my linked list. Let's assume 10, 20, 30, 40, 50. What I need to do? Yes. Correct, correct. Anyway, we need to start from start. So from start. So print start value. Move next. Print value. Move next. Print value until it reach null. That's all. Always go with start node. So start node dot next. So from start to next, print value. From next to next, print value. Continue the same step until it reaches null. Okay. So whatever we discussed, let me implement with small program. Then I'll implement with class. So I'll start with the simple data. Then we will go to class wise. Shall I start with a simple linked list program, guys? We will again come back to all the topic algorithm in terms of Java coding. Kudus, Madhu, Praveen, Ramya.
Yes, ma'am.
All right. So that's what I'm telling you. I'll start with simple data, whatever we discussed, 10, 20, 30. Then we will discuss heterogeneous data in terms of class. So in linked list, we need to do certain operation again and again. So it is advisable to use switch case loops effectively, that particularly do while loop. Linked list demo. So I'm going to do a two program. So just to make you understand linked list first, then combining heterogeneous data, which is our class block, with linked list. Please pay attention. Don't engage with any other work. No package, nothing. What do you mean by while of true? What is this line indicates?
Infinite loop.
Condition true.
Which is while of true means
It's loop forever.
Correct. While of true, while true. What is the speciality of loop? While loop, it will repeat again and again. So if I give while of true, this will become, this block will be repetitive again and again. Again and again in the sense I need to stop. I will stop in my option way. So the same thing you need to implement in your projects. Listen carefully. So I have certain operations: insert operation, delete operation, view record operation. Listen carefully. At last, I'm gonna do exit operation. I want to do this insertion, deletion, view repeatedly based on the user choice. If the user wants to stop, then I want to stop. So in order to indicate my application to repeat until the user needs to stop. So you can use this while infinite block. It's not infinite actually, it is repetitive block. It stops based on the user choice. Enter your choice. So based on my choice, I want to perform operation, insertion, deletion, data, whatever the data, linked list data I want to view, and depend upon my choice, I need to exit. Go for scanner. So these type of repetition needs to be used in your project. Int choice is equal to scanner object dot next int of switch off choice. Guys, listen carefully. Case 1. I need to complete the program. I'm just constructing my main. Case 2. Case 3. Case 4 will be. What is case 4? When the user press 4, what I want to do, I want to exit from the program. So what is the functionality function to call to stop your application? I think I introduced in your batch. We have a method called as exit method. And if I pass 0 to this, it will stop my execution. And if it is default, I just wanted to throw a message, enter valid choice. Is 1 to 4. Is that clear till now?
Yes, ma'am.
Yes, ma'am.
Right. So if it is 1, I want to insert. 2, delete. Sorry, 3, view the record. Okay. So in order to handle my linked list operation, let me create a class. Okay. So what I want to do, I want to go for a node. So again, I'm repeating, node consists of heterogeneous data. So my node may contain alphabets, strings, numbers, and address of another node. So in Java, in order to have a collection of heterogeneous type, what concept we will use? What is used to collect collection of mixed data type? I said the same yesterday itself. Class. So my node is nothing but class in Java. In C++, they have mentioned as structure. But in Java, The class is a type where it holds all the mixed type of data. So in linked list, a node can be represented with the help of class. What node consists of? You take this diagram. I assume like this is node. Node consists of two things. What are all those two things?
Data and address of next.
Address.
Address
Data
of
and
next
address.
node. Let's assume my data is number. Address of next node is nothing but another node. See here, this is my node. It consists of data, and address of next data is nothing but again the same node. So what else is required inside a class? If you want, I'll create a separate class, no problem. So in Java, linked list node is nothing but a class. And class consists of my data. Here I'm making the data as number since I was discussing about what is that 10, 20, 30, 40. So class consists of variables. What we need to do with those variables?
Constructor.
If it is in same package, getSet is optional. Shall I continue? I'll close everything. See here, this is my node class. Node consists of my data, and address of next node is nothing but again one more node. And I'm doing all my operations here. Can I proceed for linked list operation? Is this part is clear so far?
Yes, ma'am.
All right. So let me create a Java class, and I'm naming this class as linked list operation. Operations. So what are all the operation I want to do? I want to do insert operation. Insert. So what I want to get in my insert? I want to insert a number. That's all. Int number. I want to delete number. And the third operation is display. Do I want to pass any parameter to display? No, not required. Anyway, it needs to start from the beginning. I want to do insert, delete, display based on the user choice. All right, listen. If it is case 1, I want to enter data to be inserted. Get the data. And you need to pass that to the class. What is the class? Linked list operation. So create object for linked list. See here, create object for linked list operation. So under case 1, I want to call linked list operation dot what method? Insert method, and in insert method, I want to pass the number which I got as an input for inserting. I'll copy paste the same for deletion, except I want to call the method delete method. And in third switch case, just to display. Data in linked list. by using linked list operation dot display method. I know it is becoming a lengthy program, but I am doing everything in front of you. If you want to modify anything, I'm ready to do that. So in main, we created object for scanner and a linked list operation class. So repeatedly, we are doing the process of insertion. Insertion, I need to get the number and I want to insert. Deletion, I want to get the data and I want to delete. View, nothing but I just wanted to display. And exit, invalid choice. That's all. I'm not going to do anything with main. The rest of the things we are going to do with operations. Shall I proceed with operations?
Yes.
Okay. Nothing new concept, whatever we discussed. So let us start with insert. Whenever I am inserting the list, there were two choices. One is the list is empty, the other one is list is filled with values. So if the list is empty, I need to follow this process. If the list is not empty, then I need to think about the position. So listen carefully. So let's assume I'm creating a start node. So start is nothing but object of node class. So what I want to do here, all the time when I am inserting step 1. Guys, what is the first step in inserting? I think I don't want to initialize this. Only I want to initialize the data. See, in node, I don't want to initialize because we are going to point one node with another node. So just in your node, initialize your data alone. That is enough. So listen carefully. Step number 1, create a memory for new node. So node, for your understanding, I'm making a variable name as new node is equal to new node of number. So let's assume if I pass 10, I'm capturing, enter the data to be inserted 10. 10 will be passed as a number to insert method. That number is passed as a data to my new node. Listen. So I am making, I'm just checking whether it is a new empty list or existing list. So let me create a current node and I am making current node as start node. I'm checking, okay, it is capital letter. I'm checking if current node is equal to null. If it is empty node, what I want to do? I want to make my start node as new node. That's all. I'll come to else later. Let us discuss on these topics. Irrespective of whatever the operation you are doing, there should be a start node. Imagine like there is an empty list. There is no data. Yeah, of course, there is no data. In such case, I am passing the value 10. Step number 1, I want to allocate a memory for new node. So I'm creating an object. Node, new node is equal to new node of number. So whatever the number I passed will be allocated to the value of new node. So I am checking whether the start node is null or not. Start is assigned to current and I'm checking whether it is null or not. If it is null, we will come to a conclusion. What conclusion?
You want
Guys,
to start now.
If we come to a conclusion that current node is null, we will come to a conclusion that it is an empty list. There is no data at all. In such situation, whatever the node you have created, make it as start node. So what happened? My list is not empty. I allocated 10. Now I want to allocate 20. I want steps from you. Initially, I started with 10. I passed 10. My linked list is empty. So I made my 10th node as start node with this step. So what will happen this time? I am passing 20. It will go to if case.
No.
Guys, no, it will not go to if because it is not null. It will go to, we need to write in such the way it is not empty, it is having value. So we need to have an else block. So now tell me what is the step? I'm creating a new node, which is my 20 node. Now 20 is my new node. And my current is pointing to start and current is not null. Think about it. I know it's a tricky topic. My question is just with 10 and 20, guys. Okay, I'll go with you. So let's modify in such the way we will start with this algorithm. You remember this? Where is it? Yeah. So let us have a demonstration on how the node is inserted at beginning of the linked list. For example, let us follow the algorithm. Please come with me. We have 10. We made it as start node. So now I want to insert 20 and I want to make 20 as start and 10 as next. Shall we?
Okay.
Yes.
Yes, ma'am.
We will do. So again, I'm repeating. In such a situation, 10 previous will be 20, 20th next will be 10. Guys, no problem. We will go with the general English term. So I'm making this as previous and this as next. So in such situation, 10th previous will be 20 and 20th next will be 10. That also we can make. So since this is our first algorithm, I thought we'll go in this way. That also possible. One after another is also possible. And I know there were some confusing terms. Let's make it as simple. Those terms were start node, new node, and current node. And I'm going to introduce one more term called as previous node and next node. Nothing but all are pointing to a linked list node. When I started as a fresh, my start node is my start is the first empty node. I am making the newly created node as start node. I am making the newly created node as start node. So if I have 5 nodes, if I come to fifth node is considered as a current node. So fifth node previous will be 40. Fifth node next will be null. By the way, all the technical terms are pointing to the linked list node. So wisely we need to handle with previous and next with respective to current node and new node. Always new node will be the the object name which I have created for the newly created node. New object created. Either it can be 20 or 30 or 40, anything. So let us have a demonstration on inserting at the beginning. We already assume like 10. I want to insert 20. So I'll be creating the node, and very important, I want to establish a relationship. So how to establish a relationship? In order to establish a relationship only, I've introduced 2 terms, which is previous and next. Programmability, we need to deploy this relationship, previous and next. Either you can go for previous or you can go for next. If you want to do both, it comes under doubly linked list. Fine, that is also fine. Okay. Can you relate all the 5 terms, guys? Start, new node, current node, previous and next.
Yes, sir.
Yes.
All right. We will do. So before that, I would like to introduce 2 additional objects called as next node and previous node. So if I want to connect one node with another node, we will go with this next node and previous node relationship. And in OOPS, object-oriented programming class, you can go between next to previous and previous to next relation. With whether I can introduce. Yeah, I need. So I am generating its corresponding getter setter. In order to establish a relation between one node and another node, to and fro can be done with memory address relationship. For that, I'm introducing an object next and previous. So you can able to access next and previous with the help of corresponding getter method. Because it is not fixed, I cannot initialize inside constructor. Only values can be initialized inside constructor. Its memory can be retrieved with the help of getter. And it can be set with the help of setter. So get is used to get its address. Set is used to set its address. Earlier, I had node with number. So number you can initialize with the data which you have passed. But I cannot initialize my node. Instead, whenever it is required, I want to get the node. Whenever it is required, I want to set the node. I am setting my next node and also I'm setting and I'm getting the previous node. So complete it. Then we can proceed with the operation. Nothing but I have generated get set for node, both previous node and next node. So we started with assume like 10. and I want to make 10 as start node. Whereas now what we are gonna to do it is, I want to insert 20. 20 is gonna to be my start node and 10 is gonna to be my current node. So listen. As of now, 20 is a start node. So what I want to do, and 10 is a start node, 20 is a new node. Listen carefully. This is my new node. New node is 20. 20 dot set next address will be my start node, which is my, oh my God. So I want to make my start node as new node. Story over. Please pay attention. It's not 10, it can be any value. For the first time, let's say I passed 75. So 75 is passed as a number to my insert function. I'm creating a new node and I am passing 75. Initially, I don't have anything. My start is null. So start is assigned to current and I'm checking current is null. Yeah. In such situation, 75 is made as start node. 75 is considered with the variable new node. So now I am passing, let's assume 75. So now I am passing 70. 70 is my new node. So now my current is not null, it will come to else case. In such situation, what is a new node? 70. So new node's next address is, we are making it as current node, which is the start node. And we are making the newly created node as start node. I'll show you, wait, I'll come to delete after some time. Let me display the data. Same thing is applicable. So let's assume I made 65 and then we made 60 because we are gonna to insert in the beginning. You modify, we will go one by one. So at last I want to make 60 as my start node. So if I want to display 60, 65, 70, 75, from where I want to start? Can you help me in completing this display? From where I want to start? I want to always start from start node. I want to repeat until my node is not equal to null. System.out.println the current node dot number. That's all. Display node is equal to display node dot next or get next. I'm starting from 60. I am printing the number associated with my 60. I am moving to next node and then I'm printing the number in the next node. Again, next node until it reaches null. I'll show you the output. Select your operation. We have 4 operations. Let me start with 1. So let me insert 75. Let me insert 70. I'm repeating. Can you see? Every time the loop is repeating because of while of true. Again, I'm inserting 65. Again, I'm inserting 60. Can I view the output? The output is in front of you. 60, 65, 70, 75. I'll show you. Let me insert 55. Let me show you the output. Again, I'm telling, we have written the code in such the way we are going to insert at the beginning. Same thing we can do for the other way. So I add 75 and then 70, 60, 65, 55. Other way is also possible. I started with 75. I want to insert 80, 85, 90, any number. That is also possible. But we will do that after some time. Try to understand. And this is to traverse. 1 second, 1 second. Take time, you can use your note and pen, do the node insertion manually.
Can I explain else part once again?
Which one?
Else part.
Else part. Okay, all of you pay attention. We have, assume like we have 60, 65, 70 and 75. For your information, 60 is my start node. I want to insert 55 and I want to make 55 as a start node. So that is a step. So again, whenever, 1 second. So every time when you call insert of 55, what is happening? New node is created and the new node is pointing to 55. And we are declaring a variable current, and current is pointing to 60, which is the start node as of line number 8. And we are checking whether it is null. No, it comes to else. What is a new node? 55. So 55 next address, we are making it as current node, which is 60. And we are swapping the start node as the new node which we have created. By the way, 55 will be connected with 60 in forward direction and 55 is made as start node. Okay, let me scroll down. Always we are traversing or printing from first node. Line number 28 is important. All node, display node, start, current, new node, everything is an object. By using object, we are calling number. Then only we can able to print the number. Is that clear? Any confusion? Not a big code, hardly 5 lines of code, but logic is very important. Yeah. No, repeat your question. Mm. 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 Yeah. Correct. Your interpretation is correct. Remaining all connection and address remains as such in the memory. We need to modify the code according to the insertion position. Make the next field of new node pointing to the start. Next field of new node pointing to the start. And make your new node as start node. So always we need to start and we need to continue the operation until we reaches null. So use loop. So start node dot number And we need to go to the next node. So display node is equal to display node dot get next. So by the way, we are repeating the operation and we are printing the data available in the node until it reaches null. Shall we continue with delete? So delete is pending.
Yes, ma'am.
Enter your choice 1. Enter the data to be inserted 100. Again, I'm inserting 90. Again, I'm inserting 80. Again, I'm inserting 70. I'm inserting 60. So let me view the record. So 100 will be the start node, then 90 will be start node, 19th next will be 100. So likewise it goes on. Yes, as you said, remaining memory same. 80, 90, 100 will be there in a memory. Only we are doing modification between 60 and 70 at this moment. All right. So assume I have 60, 70, 80, 90, 100. I want to delete 90. What is an algorithm?
Locate 90.
Locate 90 first.
Yeah. So, guys, so let's assume I have 60, 70, 80. Let's go with detailed step 100. So by the way, this is my linked list. 60 is a start node. And here we have null. So very important step is let's go to delete. Let's assume I want to delete 90. So this is what we discussed some time back. I want to locate the node which I want to delete. So let's assume I want to delete 95. Do you have 95?
No.
No.
At
No.
the time I want to say the error message. So it's very important to locate. So let's assume if there is an empty list. So chances are there may be an empty list or nothing to delete. There is no item. So, or I can say no such item to delete. And the third case is, yes, we need to delete. How to delete? You need to follow these 2 steps. So I want to ensure there is no empty, the list is not empty. And it's very, very important. I want to locate 90. If I could not able to locate 90, there should be this error message. Am I making it sense? I want to ensure the list is not empty and I can able to locate. If I not able to locate, go with this error message. For example, I have located 90. So make the whichever the node you have located as deleted node. Tell me what I need to do. I'm locating 90 as delete node.
Searching.
Yeah. All right. So what is step 1? We will go by this way. What is step 1? We need to ensure that it is not an empty list. So make your current node as start node, and we are ensuring that start is null, because by starting itself, we will come to know if starting is null, we can display the message. Let's assume written. It's an empty list. Let's assume we are returning string. Else. Else also we have two different cases. One case we want to delete the item. The other case we want to return data deleted. The other case take the same linked list example and follow all the steps. So initially, I'm taking the start node. If the start node is null, I'll come to a conclusion it is an empty list. If the start node is not null, what is the next step? I want to locate the item. How to locate the item? It's very, very important. Listen. Come on, guys, please talk in theoretical case. How to locate 90? Irrespective of 90, 80, 100, where you will start?
Start.
I'll take additional 10 minutes, guys. Excuse me, because I'll complete it. It's a simple demo. It can be anything. Always I need to start from current or start node. Listen, I want to repeat. So I'm taking my start node, current node. I'm making it as current node dot number equal to whatever the number I want to search. So let's assume I pass 90. 90, I'm comparing with the current node, not number. What is current node? Which is start node. And also I'm ensuring that whatever the current node number or the current node's next address is not null. So if it matches with the number, if it matches with the search number 90, or it reaches to the end. Anyway, it reaches to end, I want to stop. It is not reaching to the end and my number is not far. Listen carefully. Let's assume I want to start. Always start from the start node. Start I'm assigning to current. So I'm taking current node. Start node I'm comparing with the number. If the number is matches and the next node is not null, I want to continue. Until otherwise, I want to continue. If it is matches, I want to stop. If it matches, I stop there. If it not matches, I want to continue. So while not of all the operation, you continue doing the same process. Listen carefully. If it not matches with the value and it not reaches with null, continue the same process. If it matches, stop it. Story over. What you need to continue? So I want to continue every time by traversing to next. By the way, I am locating the node to be deleted. We take our case. I have 60, 70, 80, 90 and 100. My search number is 90. I am starting from start node, which is current node. Not repeat. So current dot number 60 equal to 90. Guys,
False.
current is start. False. False or false, true. Continue. What I need to do? I need to go next. What is next node? 70. I'm going to 70th node. 70 equal to 90. False. False or false. Continue. 80 is equal to 90. No. Go to next. 90 is equal to 90. True.
True.
Current node dot number, which is 90, which is my search number. True. Stop it. Stop. And by the way, I am locating the current node 90. The current node 90 is stored in a variable current. And I am confirming that current dot number is equal to search number.
Yeah, ma'am, it is.
There should be R, ma'am.
1 second. Let's assume false. False. Okay. No, it should be and only because I have not operator here. $60. Yeah, this is applicable only if it is a middle number or the first number. It is not applicable for the end, right?
Yeah.
If I want to delete 100, assume like current reaches to current is in 90. So current node is 90. 90 is comparing with 90. False. And current node 90 is dot next is not null. False. Anyway, false and false. Not of false will be true. And it goes to next node 100. 100 matches with number true. Current dot next not equal to null, but it is equal to null. True and true will become true. It won't possible. So we can add one more if required. Point accepted. Again, I'm repeating, there were three types of insertion and deletion. It may vary, guys. Can you see the bottom second point? In both insertion and deletion, we will do in 3 different ways. One is at the beginning, the story will get differs. In between and in the end. I'm sure this algorithm is not applicable for the end. Is it okay now? This is not applicable for 100. Yeah, it won't support. I am applying this only for the searching element. If it is 100, we will add one more if condition and we will do. Okay, so anyway, here I want to delete 90. With this block, I have located 90. For your information, the current node is pointing to 90. So tell me, I want to delete 90. What is the step I want to do here? If I want to delete 90, I need to take the necessary steps to connect what?
Current dot get previous.
Correct. So if I want to remove 90, I need to take care to connect 80 and 100. I don't know what is 80 and I don't know what is 100. I know only 90. So 90's previous node, next address will be pointing to 90th next address. It looks like confusing, but it is a simple task, guys. I know only 90. So 90th previous, which is 80. 80th next address will be pointing to 100, which is nothing but 90th next address. Reverse is also possible. Yes. Okay, I'll complete that alone. So I'll not take much time. I need to do this connection alone. So 80 and 100 needs to be connected. By the way, I know only current. Current dot next. Let's assume I have 80, I have 90, and I have 100. So current is my 90. So 90th next will be 100. 100's previous will be set as current dot next. Even the vice versa. Current dot get previous. Once, see, either this or this. I'm telling you, or either you can put this line or you can put this line. By the way, I am connecting 80 and 100. So current dot get previous, which is 80. 80. This is my current. Current dot get previous will be 80. 80th next will be set as current of next. Yeah, both are same. Or current dot next, which is 100. 100 previous will be current previous. See guys, it's not necessary to do both the step, either this or this. By the way, I am connecting 80 and 90, 80 and 100. There is no picture in 90 in my linked list. So next time when I traverse, my data will start from 60, 70, 80 and then 100. 90 will not come once if you delete 90. We will continue with the same. Also, instead of number, as I said, we will continue with heterogeneous type after lunch break. No worries. So guys, go on a lunch break. I'll copy the code because I made with the proper syntax only. It's not my algorithm or pseudo code. So let's copy this code. Where in delete operation, let us return the appropriate message. And I am making this a search number to differentiate. To differentiate a regular number and the number which I want to search. Oh, I made pre set pre, get pre. So let's go on a lunch break.